Welcome back, everyone. We're building Minecraft circuits, which is working out pretty well. Before the break, we got the chat window up. Before the break, we finished this thing. So this is essentially a counting circuit in Minecraft, using just command blocks to place and to remove, using repeaters to create delay, and comparators so that we can check for the presence of blocks. And it works like this. We get a signal, and this command block adds the redstone block there. That's as if we were counting to 1. We get another signal. This command block checks if that redstone block is there, and if so, this command block adds another redstone block. Third one works similarly. So here, in just the space over here, in a very easy to understand way, I think, we've created a circuit that can count to 3. Here we've got a very simple reset for that circuit. So each of these command blocks remove the redstone block there, and when we step on this, the circuit resets, and we can start counting again. Now, you may wonder why this is even useful, why counting something like this is useful, and let me tell you while I clean up here. A while ago I was at PHP DPC, actually, DPC, which is the Dutch PHP conference, and I think it's called DPCon now for various ambiguity reasons. But I was at this conference, and Silverstripe, who I work for, had a booth, and one of the things we had there was we had 2 iMacs set up with a mouse and a keyboard, and on these iMacs we actually had the game of Battleships. So on the one side, let's get some wood and try and illustrate this thing. There's a big ocean between the 2 players, and they each had a boat that looked sort of, I guess it was 5x5. So they were each in a boat like this, and each boat had like a little flag. And then on the floor of this boat there were switches. They weren't pressure plates, but I'll use pressure plates just to illustrate. There were switches on the floor of the boat. And so if you were standing in this boat and looking at the other player in their boat, you couldn't actually see what switches were pressed or not. So the first player in their boat selects some things. They'll push buttons, in this case it's pressure plates, and that combination is saved. And then the other player in the other boat suddenly gets a set of buttons, and they have to try and guess what the first player picked. It's kind of like a game of Battleships, where the first player hides a combination and the second player guesses that combination. And if the second player guesses incorrectly, in other words, pushes a button that the first player didn't push, then there's a bit of an explosion. No one actually gets hurt, but it's just a bit of a visual effect. A bit of TNT goes off in the center, and so you can tell if someone has guessed correctly or not, which is pretty rad. Now this whole circuit has to count. The first player who picks buttons to hide, well, it's got to make sure that they only pick 3, and then it's got to remove the buttons and prevent further picking, because the first player's only got to hide 3, right? That's part of the game's rules. So the circuit's got to count to 3, and then hide these buttons, and then display the buttons on the other side. And on the other side, that circuit has to count to 3 as well, because it's got to count for each guess, whether that player guessed the right thing or not. It's got to count so that after they've guessed 3, the whole board can be reset. So there are actually 2 counting circuits in that game, in that, I guess you could call it a game of Battleships. One for the person making the guesses, and the second for the other person guessing. Sorry, the first person hiding and the second person guessing. There's also other circuitry, like to match the guesses so that you can tell if it's correct or not. There's a whole lot of Boolean logic there. And basically what that comes down to is AND gates. Now if you've programmed for any amount of time, you're probably familiar with the structure. It's like saying if condition 1 and condition 2. And in Minecraft you can simulate this by something like this. So I'll get switches out because they're the most useful for checking this thing out. character anymore. I'll get switches out. And so the way that redstone torches work is when you feed a signal into them, then they turn off. Almost predictably. There are some edge cases where it works kind of differently, but generally when you feed a signal into a redstone torch, it turns off. We can look at that like this. If we add redstone here, that's not going to do anything. What about if we do this? No, that won't do anything. Let's do something like this. There we go. Okay, that illustrates it. So that redstone torch is emitting a signal, but if we turn this on and feed a signal into it, it switches off. Now we're doing something similar here. We've got these two redstone torches, and this redstone signal is feeding into this redstone torch, so it's off. If we add one signal here, we turn this off, but that one's still on, so the redstone signal is still emitting, so this is still off. If we turn both of these off, that signal turns on. Which is cool. I mean, it's kind of like a NAND gate, I guess, where both of these signals need to be on. But you can invert signals as well. You can have, if you've got a signal here, let's do a switch again. If you've got a signal here, you can actually invert the signal like this, using the same redstone mechanics, same redstone torch mechanics. So if you switch this, that signal inverts. So this is like an AND gate, and this is like a NOT. It's like a negation. And using just these two, you can do, they're a complete set of binary operations. You can do ORs using similar stuff to this. You can do NANDs and XORs. You can do all sorts of gates like this. And you can, of course, do them more, you can make them more compact. And there are, people are really nuts about making these things really compact in Minecraft. But the basics are there. Now, think about how we apply that to Minecraft here. Someone hides these things, but we store in a grid of 9x9, which we select the first one. And then we can use AND gates to compare the guesses. So if the person hides the second one, and the person guesses the second one, we have signals that we can compare in an AND to say whether both of them are selected correctly. And again, this falls in third counter because if you have 3 correct guesses, in other words 3 signals fed into a circuit like this, well then you can do something on condition of them winning, like firing fireworks off. That basic, well I guess it's not basic considering the amount of circuitry you need, but that small game of battleships incorporates the counting circuits, incorporates ANDs and NOTs and OR gates. And basically this circuitry that you see in front of you here, this is all that is actually required to make the game of battleships I described. And once you have working circuitry, you can really go nuts in terms of decoration, and you can make it look really awesome and make it work really well, which is really fun. It's really fun. Now, people have done really complex machines with Minecraft. I've seen interesting things like I mean, this one guy built, emulated a Commodore 64, and basically developed a programming language and an IDE. So you start up this Java-based IDE and program in this programming language while you have the Minecraft map open. And this IDE transmits the programming code to the map storage. It uses this idea of storage and registers. It uses this idea to store programming code. So you can write programs for this map and have the map computer execute those programs. And it comes with some default ones like Paint and Snake, but you can basically write in a general purpose programming language and it'll store that programming language in memory in the map using concepts like this, which is absolutely nuts. Like, the complexity of that is incredible, and it's got like a 16-bit color display of like 32 by 32 pixels. It's pretty nuts what this computer is doing. But that's all using these concepts. It does more complex things with Redstone, with command blocks than what I'm doing. I'm basically just using command blocks to set and to remove and to test for the presence of other blocks. It does really insane stuff. But that's a really interesting thing. I mean, there are other... I was talking to someone about this today. There are other things like the note blocks that you can use, and you can set these up to play different frequencies. So you right click them and then you give them like an input signal. And what you can do, what I've seen done before a couple times, is that people have set up elaborate combinations of these note blocks and accompanied it with things like detector rails. So let me get this stuff out and let me see if this works. I've never done this before, so I don't even know. But basically, you can have a minecart that that the player gets in and rides along to see, to listen to like music that just gets played next to the minecart as it goes along. Does that even? I forget. I'll get out. I'll build this up because I've just because I'm a moron and I've just remembered how this actually works. Okay, so they have like elaborate minecart systems, and those fire off combinations of music blocks to play music as the person moves through this elaborate rail system, which is pretty awesome. That uses less of the Boolean operations and binary logic, but it's still pretty rad. Like, I'd like to see a combination of those things happen, like a really interesting story mode map that has like a lot of mechanics like this. And there are maps that use these things to do really awesome story arcs. I just haven't dug into many of them, but I'd like to. I'd like to, and I'd like to learn some of the tricks that they're doing. And maybe you can think of interesting things to do with this. Maybe there's like a little game that you want to build, or maybe there is some kind of electronic circuitry. If you're into making stuff like with Arduino or Raspberry Pi, and there's circuitry that you've made, you can actually emulate that stuff in Minecraft using these mechanics. In fact, this is much closer to electronics than it is to programming. It's just that programming is very close to electronics anyway. So that's really interesting. By all means, experiment with that kind of stuff. I think that's about all I'm going to cover tonight. So I'll just close that and talk a little bit more. So I think that's all I'm going to cover tonight. It was a lot of fun getting back into this stuff, and Kieran's suggestion was good about putting it in the Minecraft Twitch channel, but I wanted to refresh my memory about how this stuff works before I put it in there, because people rage, and this was more fun and for me and for refreshing my memory. So I'm interested in doing more of this stuff. I think next time I do Minecraft circuitry, I'll probably look at making clocks, which I've done before, which are pretty useful. So there, you can combine those with detectors and comparators and do some really funky proximity detection and player location detection. It's pretty cool. So clocks are really cool, redstone clocks, but they're really quick and easy to make. I'll probably look for some kind of another kind of circuit to explain in code and then to build with this, or even some electronic circuit and try and build with that. But that's the next time I do this. It's not every day that I stream like this, which makes the name of the stream quite deceptive, but it's usually going to be about an hour ago your time, whatever time that is. For me it's 9 PM, so for you it may be 3 in the morning, who knows. But I will tweet about it, so you can follow me on Twitter at assertchris if you want to see the tweets about when I stream, or you can just follow me on Twitch and then you'll get emails when I stream. So it might not be every day, but it's usually going to be around about an hour ago your time. And that's kind of it. Thank you for